in chapter 6, only at section 6.1. And we are only going to look at one method, which is Gauss Jordan method. I accept if you prefer, I don't recommend it, but it's up to you. If you prefer, because you may have questions in MyLab Math, Gaussian elimination with back substitution. Substitution. Correct. Okay. I will not present this, but if you think that this is easier for you, I will allow you to change this method into this. Okay? It's up to you. You have the freedom. If you think that that method, you learn it somehow, somebody teaches it to you, or you read it in the book and you say, I think that this is easier for me than that, I accept it. But I will present the entire method. This is about half of this method. Okay? I will present the entire method. So I'm going to pick a problem. And page 631, I'm going to pick problem 22. And you can say you haven't even explained what this is all about. Yes, that's true. I will right this moment. Okay, I copy the system. So here we're talking about a system so-called 3 by 3. 3 linear equations in 3 variables, x, y, and z. So this is a method of solving systems of equations. They are linear. So linear systems. We are looking at linear systems with 3 equations in 3 variables. We can look at more than that. We can look at 4 by 4 and so on and so forth. There is no need. I'm happy if we understand the method, if we master the method of Gauss Jordan method for 3 by 3, we can apply it to any. But I don't want to teach endurance here. I just want to teach the method. And 3 by 3 is good enough. Okay. First of all, we have to, the first problem, as you know, I have a lot to say. It will take 20 minutes. The next problems will take 5 or 6 minutes at the most. But the first one, I have a lot to tell you. So number 1, and I don't think that this is a good color. So number 1 is I'm going to denote what it's called the matrix of the variables. Or the coefficient matrix. Better. This is better. Coefficient matrix. And first of all, you can say, wait a minute, you haven't even explained what a matrix is. Here's what a matrix is. Matrix is an array of numbers. How come? Okay, here's examples of a matrix. Notice the brackets. And the notation is normally uppercase letter, but it could be a lowercase letter as well. Okay, so here's another. This one is a 2 by 2. What do you mean? 2 rows, 2 columns. This one is a 3 by 2. 3 rows, 2 columns. So these are examples of matrices. Okay. Now, coming back to the coefficient matrix, it refers to the coefficient. So I want to remove this because I have to talk about the coefficient matrix first. So the coefficients 1, 2, negative 1, negative 2, negative 1, 1, negative 1, 1, negative 2. That will be the coefficient matrix. And it's characteristic to each system. For this system, I'm going to call it A. It's a 3 by 3, of course, because we have 3 rows and 3 columns. 1, 2, negative 1. 1, 2, negative 1. Negative 2, negative 1, 1. Negative 2, negative 1, 1. Negative 1, 1, negative 2. Negative 1, 1, negative 2. So this is the coefficient matrix. It belongs to the system, and it only has the coefficients of each variable. Okay. There is also a lowercase matrix that is made up of these free terms that are on the other side. They have to be on the other side of the equal symbol. And this is a 3 by 1. And they are 2, 4, negative 4. I don't know if we have a name for this other than the matrix of the free terms, if you want to call it. We also have something extremely important, a combination of these two, which is called augmented matrix, or coefficient matrix if you want. And here is the way we denote that. Okay, so it's also a matrix, and this side is this matrix, and this side is this matrix. How does it look? I just copy. 1, negative 2, negative 1, 2, negative 1, 1, negative 1, 1, negative 2, 2, 4, negative 4. Where does this come from? 1, 2, negative 1, coefficients of x, negative 2, negative 1, 1, coefficients of y, negative 1, 1, negative 2, coefficients of z, equal symbol, 2, 4, negative 4. So you could say from the beginning, why didn't you just show this and then this? Why did you have to explain all this? Because I needed you to understand where it's coming from. But yes, I could have from here taken this. Can I go back? Of course. Here's how I go back. X minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals negative 4. So every system has an augmented matrix. Every augmented matrix can be changed back into a system. And that's extremely important to remember. Okay, finally, what is the purpose of this? What am I trying to do? At the end of the day, hopefully in 10 minutes from now, not tonight, I would like to determine the ordered triple. Whatever. This will be the x, this will be the y, and this will be the z. And this is the ordered triple. The solution of the system. Blah, 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 I plug it in, I get 2. Blah, 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 I plug it in, I get 4, and so on and so forth. It's the only solution that verifies all these 3 equations. That's what I'm after. And this is how the method comes into play. But only after I have created the augmented matrix. If I don't have the augmented matrix, I cannot start the method. So let's recap quickly. I have a system, I create the augmented matrix, and now I apply this method that I'm going to talk about to determine the ordered triple. I determine the ordered triple like I did with all the systems, except when I got lazy, and I left it on your shoulders. Then I go back and check. Okay. So this is something similar to elimination, something similar to substitution. This is a new method. that we are talking about. Okay. And now the method. What are we trying to do with this augmented matrix? I want to start with the augmented matrix, and through a sequence of steps, I want to get this augmented matrix look like this. I didn't copy it. Let me copy it so it's clear what I'm trying to say. I'm not going to do the method here. There's not enough room anyway. But let me write it. Through some steps, and I will explain the steps. That's what the method is all about, Gauss Jordan. So to this matrix, I apply the steps from Gauss Jordan, and this is what I want to determine. I want to change this into this after the steps are applied. And you could say, what is this? That says x plus 0 equals this, which means x is this. 0 plus y plus 0 is this, which means y is this. And 0 plus z equals this is that. So once I manage to change this matrix into this, I finished. I solved the system. I got this for x, I got this for y, and I got this for z. Now, what are the steps? I can only apply 3 steps. Only 3 steps are allowed, or I should say 3 operations. Only 3 allowed operations can be applied. 1, 2, 3. Let's see what they are. 1, swap rows. What? What does that mean? Well, swapping rows meaning I can make this equation the second equation, and if I decide that, I can make this equation the first one. I can swap these 2 equations. Of course I can. The system will not change. The solution will not change. So if I need to swap rows, I am allowed to. What does that mean? It means that the first row will be 2, -1, 1, 4, and the second row will be 1, -2, -1, 2. If I choose to do that, if I need to do that, that's the first allowed operation. Second allowed operation, multiply or divide any row. I know that any row means an equation. This is the first row, this is the second row, this is the multiply, divide any row by a non-zero. It cannot be 0. Number. Okay, have I done that before? Many times. I multiply this equation by 5 if I wanted to. 5x minus 10y minus 5z equals 10. I can multiply this equation by 3. 6x minus 3y plus 3z equals 12. I can always do that. Can I divide this equation by 5? I wouldn't, but I could. -1/5 x plus 1/5 y minus 2/5 z equals -4/5. Of course I can. So I'm allowed to multiply or divide any row by a non-zero number. And the last one now. Before I have to go back and dig my previous lecture for a moment, not the calculus lecture, but your lecture, because I want to show something so we understand where this is coming from, the third one. Because the third one is sometimes more difficult to understand. So I'm going back to the previous lecture in which, here, see what we did on problem 46 on page 555? We multiplied both sides of this equation by 2 because the purpose was to eliminate y. So we copied the first equation, we multiplied the second one by 2, We added these two equations and we got the third one. So what did we do again? We multiplied an equation by 2 and we added the result to another row, to another equation. One more time. We multiplied an equation by a number and we added the result to another equation to form a third one. That's what I have to write. That's the third allowed operation. Now this can go. So multiply any row by a non-zero number and add the result to another row. As I promise, till I finish with the first problem, it will take a while. It's a lot to explain. So only these three operations. I cannot do anything else. I can swap rows if it's needed. I can multiply or divide any row, which is an equation, by a non-zero number. And the third, which is extremely important, I can multiply any row by a number and add the result to another row. Okay. Steps. And then we can start. So the result has to be this, whatever. These are numbers. I just don't want to put numbers in there because I don't know the answer. And a circle. So triangle, square, circle. Okay. So the order of the steps is absolutely mandatory. If you change the order, you're not going to get the answer. So here's the order. This is number 1. So I'm going to write a 1 next to it. Then I have to obtain the 0 corresponding to 1 to this row. I'm sorry, to this column. Then I have to get the 0 at the bottom. So this number will help me get these two zeros. Step 1, step 2, step 3. Of course, the same thing here. Step 1, step 2, step 3. Step 1, step 2, step 3. So the key is to get the 1 of the column and then the corresponding zeros. Then the 1 of the column and then the corresponding zeros. Then the 1 of the column and then the corresponding zeros. And this is the elimination part that we already know. Once I get this, I can eliminate the other 2. Once I get this, I can eliminate these 2. Once I get this, I can eliminate these 2. A lot of words, but now we're ready. Let's do it as slowly as possible for the first one, and then this is it. Finally, I'm copying the augmented matrix. 1, -2, -1, 2, -1, 1, -1, 1, -2, 2, 4, -4. We do not ever write the equal symbol between matrices. We have to write just an arrow. Do not write the equal symbol. This matrix will not be equal to the other one that I'm going to write in a minute. My first step has to be the 1 in the first column. Yay! I have it. Now, using this 1, I have to determine or create a 0 here, and then I need to determine or create a 0 here. That's my next target. I got the 1, I need the zeros. Okay. And I have these 3 operations that are allowed. Will I swap rows? No, no. Will I multiply and divide? No, no. I have to use this. I have to multiply this row by a specific number that you will give me in a moment and add it to this row. So multiply this by a number, add it to this row to get the 0 here. So I have to multiply row 1. We always write here what we're trying to do. We're multiplying row 1 by, you will tell me by what, and add it to row 2 to eliminate the 2. So of course, this is R1, this is R2, this is R3. And then I'll come back and multiply row 1 by something else to add it to row 3 to eliminate this. So what do you think I need to multiply by?